Hi folks, how you doing? Hope you're all doing okay. Welcome back to the Space Unit. Today we're going to be looking at the Big Bang and the electromagnetic spectrum. This is just going to be a short video, I'll be introducing the basic knowledge that you'll need whenever you're answering any questions in an assessment or tutorial about the Big Bang or the EM spectrum. And your next task will be to watch two separate videos that I've looked out that hopefully will build on your understanding. A lot more visual, a lot more animations that will really help you. Okay, so base knowledge in this video and building on that knowledge to hopefully help your understanding in the next two videos. But before we move on today, let's look at a wee starter to revise what we did last time. So pause the video and attempt these questions and come back and we'll go through the answers. Okay, welcome back. What is meant by the term light year? How fast light travels in 1 year. How many seconds are in a year? 365 times 24 times 60 times 60. So that's 365 days times 24 hours in a day times 60 minutes in an hour times 60 seconds in a minute. That gets you 313,536,000 seconds. If light travels at 300 million, that's 3 times 10 to the power 8 meters per second. How far will it travel in 1 year? So you would get 3 marks for this. 1 mark for the formula, D equals VT. 1 mark for putting the numbers in, 3 times 10 to the power 8, the speed of light, times 365 times 24 times 60 times 60. That's the time in 1 year in seconds. And that gets you 9.4608 times 10 to the 15 meters. So well done if you got them correct. So the Big Bang. Here is everything you need to know about the Big Bang. The Big Bang Theory states that the entire universe started at one single point, which expanded and cooled rapidly. The estimated age of the universe, as postulated by the Big Bang Theory, is 13.8 billion years. So, this is the stuff we've been doing before, like forces and projectiles and everything. That's like easy to see, easy to test, and easy to record. That's quite, I don't know, like obvious kind of stuff. But see, when we talk about the Big Bang Theory, we're getting into the realms where scientists really don't know what caused the Big Bang or if there was anything before it. I mean, have you ever heard of the Big Bounce? That's terrifying stuff. The Big Bounce, that there might have been another universe before this, but that's just theories. So this is where science gets really exciting, when we don't actually know. It's at the cutting edge of science, where we don't actually know the answers, but we've collected all the information, all the evidence from the universe that we can get, and we're using that to make the best scientific guess we can. Okay, and the Big Bang Theory is a great example of why science is so brilliant. But we should just remember, as mind melting as this stuff becomes, and as big and vast and scary as this material might be, these are the only two facts you actually need to know just now. Big Bang Theory states that the entire universe started at one single point, which expanded and cooled rapidly, and the estimated age of the universe, as postulated by the Big Bang Theory, is 13.8 billion years. So if you know these two facts, you're good to go, okay? So let's move on to the electromagnetic spectrum. Signals with a range of wavelengths can be detected from space. These signals help us to develop our knowledge of space. Different wavelengths require different detectors. So the electromagnetic spectrum, that signal is just coming from space, and we can pick that information up using different detectors. And here they are. So this is the wave type. So this is the electromagnetic spectrum here, and these are the detectors. So any radio or TV waves that are in the electromagnetic spectrum, we can detect them with using an aerial. Microwaves can be detected using an aerial or a probe. Infrared waves can be detected using a thermometer. Visible light, we use a refracting telescope. Ultraviolet light, we can use fluorescent paint. X-ray, we use photographic film. And gamma, we use a Geiger counter. So the EM spectrum and their detectors. That's what we've got there. And then finally, we've got the line spectra. Each element has a line spectra that can be observed and used to identify the elements present in stars. So the top one, we've got the continuous spectrum. That should ring some bells from maybe second year when you were doing what's white light made of. So this is the continuous spectrum, the absorption spectrum, and the emission spectrum, okay? So that is what we've got there. The second video I'm going to show you that explains these in a lot more detail, how they come about, and it also gives you a great example of a question that you might be asked that's to do with these, okay? So it really simplifies it and really shows you how to do it. So hopefully that helps you. And that's pretty much it, guys. So the Big Bang and the EM spectrum. And so please now go and watch the other two videos, and that will really hammer home the points, and it will really get your understanding up, okay? So thank you very much. And as always, just ask us any questions in class and on Google Classroom. If anything's not clear, please just let us know. Thank you very much, and I'll see you in school.